Types of structures. All structures built can be classified into the following groups. 4.1. Mass structures. Mass structures have been used since ancient history. They are based on the strength, resistance, and permanence of natural structures that can stand the test of time. They are made up of large, thick stone blocks and the accumulation of materials used to provide support. Some of the clearest examples of mass structures include the Egyptian pyramids, ancient temples, dams, and stone bridges, some of which are still standing. 4.2. Framed structures. These structures use resistant elements such as vertical pillars and columns crossed by horizontal beams to form a framework. Today, they are used to construct the skeleton of buildings and to build scaffolding. A ladder is an example of a simple frame structure. 4.3. Laminated structures. These structures are used to provide coverage and protection. They tend to be light and are usually fragile in comparison to other heavier structures. Harder, more resistant laminated structures are usually called exoskeletons. The most common structures of this type include the outer panels of electrical appliances or the sheets of metal that cover a car. 4.4. Hanging or suspended structures. This type of structure is based on the use of braces and steel cables to support solid structural elements. Braces and cables are often used in bridge building projects, which tend to have one or two large towers upon which the braces and steel cables that support the bridge rest. 4.5. Triangulated structures. Triangles are the only geometrical shape that cannot be deformed. This means that an object made up of three rigid bars that form a triangle does not change shape when forces are applied to it. Therefore, triangulation, or making triangles with resistant elements, is the most effective way to make structures more rigid and more difficult to deform. This type of solution can be seen in buildings and permanent structures, as well as temporary structures such as cranes, for example. 4.6. Vaulted structures. Arches and vaults have been used as an architectural solution for thousands of years. However, they are usually only used in special buildings, since they are difficult and expensive to build. The main types of vaulted structures are arches. There are two very delicate moments when building an arch: fitting the keystone or cornerstone and removing the scaffolding. If the scaffolding is not removed in the correct order, the entire structure could collapse. The simplest and most well-known arch is the Roman arch. Vaults and domes. Domes were the first man-made structure to imitate natural curves. This type of structure distributes the stress over its sections evenly and is used extensively by architects when they want to emphasize the sense of space and lightness in a building. A vault is a concave body supported by the walls that surround a space for which it forms a cover or roof. There is a wide variety of vaults: barrel vaults, rib vaults, and groin vaults, amongst others. A dome is a type of spherical vault that is made by turning an arch on its symmetry axis. It is used to cover or close a generally square, octagonal, or circular space. In the past, vaults and domes were used to build churches, cathedrals, and palaces. Nowadays, they can also be found in airports, stations, and shopping centres. 4.7. Structural failure. In order to prevent any potential failure that might occur in a structure, it is important to carry out preventive maintenance work and, of course, adhere to a suitable design carefully. The main causes of structural failure are Material fatigue. Structures are constantly subjected to forces and loads. In many cases, loads are not static, but rather move constantly, as in the case of bridges designed for vehicles. As the load moves, vibrations are sent to the elements of a structure through small and repetitive impacts in every direction. This means that the material the structure is made of is subjected to more stress than expected and wears down more quickly. Rusting and corrosion. All materials, especially metals, are affected by oxidation processes, rusting, which often lead to corrosion. This gives rise to loss of mass in the material affected. Special paints and other anti-corrosion techniques are commonly used to prevent this. Incorrect structural design. Structures are affected by many factors, such as the optimal selection of materials, calculations, locations, how the different elements are arranged and how they are assembled, in addition to many other variables. If a mistake is made in the planning and design process, or if important circumstances have not been considered, structural failure will occur over time. When materials reach a certain level of wear, they can even break and thereby cause the whole structure to collapse.